So welcome, this is video for IBDP AAHL TC2 May-June 2022 paper 2 question number 12. The population of a particular species is given by this formula. In this context of the population model, interpret the meaning of dp upon dt. So dp, what is p over here? The population of the species. So dp upon dt is going to be nothing but what? Rate change or change of population. Change of population with respect to WRT means with respect to time. Then show that second derivative equals to this. So what am I going to do? Let me add a page over there and write it out the first derivative. The first derivative has been given as dp upon dt has been given as kp times 1 minus p upon n. Expand this one, so dp upon dt equals to kp minus kp square upon n. So second derivative is going to be d square p upon dt square equals to k. P derivative is dp upon dt minus k upon n. P square derivative is 2p. Again p derivative is dp upon dt. Now what can I do? I can, what it says, take the constant kp upon dp upon dt times k common. So k dp upon dt common. So what is left over? 1 minus 2p upon n. I think so that is only been asked. Then again dp upon dt plug in. So what is dp upon dt? Which is kp times 1 minus p upon n. Then times 1 minus 2p upon n. So this is the substitution of dp upon dt. So that we have proved it out. Next part of the question. Hence show that the population of the monosphere will increase at a maximum rate when p equals to n upon 2. Justify your answer. Increases at a maximum rate means we have to find it out maximum value of dp upon dt. Maximum value of dp upon dt. So maximum value of dp upon dt means its derivative should be equals to 0. Derivative of dp upon dt should be equals to 0 means second derivative should be equals to 0. So reading the question makes much more sense over here. Maximum value of the rate means derivative of the rate should be equals to 0 means the second derivative equals to 0. So what is the second derivative? Just now we got the second derivative as k square p times 1 minus p upon n times 1 minus 2p upon n should be equals to 0. So either p equals to 0, 1 minus p upon n equals to 0, 1 minus 2p upon n equals to 0. So we get three cases: p equals to 0, p equals to n, and p equals to n upon 2. From these three conditions I get the values. Now out of these three, only one condition will be satisfying. What is that? So let us do 1 minus p upon n. If p equals to 0, dp upon dt will become 0. But I want the maximum value. So this is rejected. Now if p equals to n, dp upon dt will become kp kn times 1 minus n upon n. This again becomes 0. So therefore this is rejected. Then finally, if p equals to n upon 2, then only I'll be getting dp upon dt equals to k times n upon 2, 1 minus n upon 2 upon n. I have some value which is greater than 0. Therefore, only it is possible when p equals to n upon 2. So this is the justification. Easy justification rather than drawing by the graph. Next, hence determine the maximum value of dp upon dt. So what am I going to do? I am going to find this value. So we shall move this entire thing. So I am going to find this value, simplify this value. So that's going to be k times n upon 2, 1 minus 1 upon 2 upon 1. So which is going to be k times n upon 2 times 1 upon 2. So kn upon 4. That's going to be the maximum value. Next, by solving this differential equation. So we have to solving this differential equation so that the solution can be got at this equation. So we need to solve the differential equation and get that answer. So let us start again in a fresh page. dp upon dt equals to kp times 1 minus p upon n. We do the variable separation. Before that, dp upon dt equals to kp times n minus p upon n. So what am I going to get it out? dp divided by p times n minus p equals to k dt. And I bring that n also. Then apply integral on both sides. I am writing now the partial fractions for this. N upon p times n minus p can be written as 1 upon p, a upon p plus b upon n minus p. So n should be equals to a times n minus p plus b times p. So let n equals to p. So p equals to bp, b equals to 1. Then if b equals to 1, then another way of getting the coefficients of n, 1 equals to, I am equating coefficients of n. So 1 equals to a, so plus 0. So a equals to 1. So what will be the partial fractions? 1 upon p plus 1 upon n minus p dp equals to integral of k dt. So it is ln p plus ln n minus p. Don't forget to divide by the derivative of basic function, divided by minus 1 equals to kt plus c, constant. What should I be writing constant? Constant I will be writing in terms of answer. So ln c. That makes our life easier. So ln p n minus p minus ln c equals to kt. So ln p by n minus p times c equals to kt. So then we have to find the value of c. So what is that? How do I find it out? C at t equals to 0, p equals to p naught. So what will become? Ln p upon p equals to p naught upon n minus p naught times c equals to kt. K t derivative t is nothing but what? 0. So what does that becomes when it is equals to 0? Ln 1 equals to 0. So ln p naught upon n minus p naught c should be equals to ln 1, because ln 1 is going to be 0. So p naught upon n minus p naught times c equals to 1. So p naught equals to n minus p naught times c. C equals to p naught upon n minus p naught. So what's going to be the answer now? I got the value of c. So ln p upon n minus p times c equals to kt. Substitute the value of c over there. Ln p upon n minus p times the fraction, it's there in the denominator, it becomes reciprocal, so it becomes n minus p naught by p naught equals to kt. I think so that is only been asked. If at all we write in proper order, p upon p naught, so n minus p naught by n minus p equals to kt. Now the last part of the question. After 10 years, the population of the municipals is 3p naught. It is known that n equals to 4p naught. Find the value of k for this population model. So after 10 years. So in this formula, I am going to plug in T equals to 10, P equals to 3P naught, and N equals to 4P naught. So what am I going to get it out? 10K equals to ln 3, then 4P naught minus P naught by 4P naught minus 3P naught, which is going to be equals to ln 9. So K equals to ln 9 divided by 10, which is going to be 0.220. That's going to be the answer. That completes the paper. See you in the next paper. Bye.